Okay, good evening. This is Professor David J. De Los Reyes. Okay, the date for today is November 5, 2023, and the time is around 10:01 p.m. Okay, my subject matter for this evening will be a continuation of my long video format topic, trigonometry, and I am now on lesson number 18. We are now on lesson number 18. So for those of you who are following my long video format topic trigonometry, we are now on lesson number 18. Okay, let's proceed. The subject matter for this evening will be trigonometry, lesson number 18, and the title of the topic is anti-logarithm. The last time around, I brought out the definition of a logarithm, the different laws of logarithm, the properties of logarithm. So for tonight, let's try to discuss the concept of anti-logarithm. How do we compute anti-logarithm? Anti is actually the, what you call this, reverse equivalent of a logarithm. Meaning to say, if we are given a logarithm of a number, what will be the anti-logarithm of that number? Let's try to define what is anti-logarithm. Anti-logarithm is the number corresponding to a given logarithm. It is something like this. Under the study of logarithm, our equation is actually under the so-called, this was taken under algebra. It's a different form of algebraic equation that is changing from logarithmic to exponential. This is it, okay? If we are given a logarithmic form and we are asked to find for the exponential equivalent, that exponential equivalent is actually the anti-logarithm. You get it? So we just apply our knowledge under the study of algebra. If we are given the logarithmic form, we just change that form to an exponential form, and we have taken already the anti-logarithm of that given number. Okay? Okay, let's try to bring out the logarithmic form. In general, the logarithm of x with the base of a is equal to n. We call this the logarithmic form. This was taken under algebra. Okay? The changing of the forms from logarithmic to exponential and from exponential to logarithmic. Okay? So if we are given this logarithmic form, if we try to take the exponential equivalent of the exponential equivalent is actually the anti-logarithm. And how do we brought out or bring out the anti-logarithm? It is something like this. We start with this. The logarithm of x with the base of a is equal to n. Okay? Changing to exponential form, or meaning to say, take the antilog. Okay? Our topic. Take the antilog of both sides. Okay? Taking the antilog of both sides meaning we must have to change the given logarithmic form to exponential form. That's the equivalent of this antilogarithm of both sides. Antilog is just the exponential form of the given logarithmic form. So with this given logarithmic equation, if we try to take the antilog of both sides, or we change this to exponential form, okay, we will take the base. The base of our logarithm is a. Okay? We take the base and we raise to an exponent, in which the exponent will be the left hand side. That is the logarithm of x with the base of a. Okay? And this should be equal to whatever you do on the left, do it on the right, right? So we get the base, we raise that to the given left hand side, and again we get the base and we raise that to the given right hand side. Okay? There's no problem with that one, right? We take the exponential equivalent of the left hand side, and we take also the exponential equivalent of the right hand side. The respective exponents are actually the left hand side and the right hand side. Okay? But if we try to simplify this one, do you know the simplification of this? That is a raised to the logarithm of x with the base of a. It is actually a. It is actually a. A raised to the logarithm of x with the base of a is just actually a. And the proper way to read this one is this. Okay? A raised to the logarithm of x with the base of a is equal to x. Okay? And the proper way to read this one, it is read the antilogarithm of the logarithm of x with the base of a. That's how we read this one. This is antilog. Our topic for tonight. Right? So, if the equivalent of this is just, this is x. This should be x. So, if the equivalent of the left hand side is just x, okay, this should now be equal to e raised to n, okay? You already got the antilog of the given logarithmic equation, and the resulting form is actually an exponential form. That is, x is equal to a raised to n. There is an n over here, so it's an exponential form already. So after taking the antilog, what comes out as an equation is actually an exponential equation, that is x equal to e raised to n. So the equivalent of this, if we try to take the antilog of this one, it will be x equal to e raised to n. You got it? Okay, you got it? So this is just an easy one because when I finish my, what you call this, algebra syllabus under my channel, okay, I got a topic there changing from logarithmic to exponential and from exponential to logarithmic, and that topic is actually under antilogarithm. Okay, so in general now, try to memorize this one. The logarithm of x with the base of a is equal to n. Okay, if we try to take the antilog of this one, what will come out will be x equal to e raised to n, and this is actually an exponential form. Originally, it was a logarithmic form. So meaning to say, when we are talking anti-logarithm, we are only changing the given logarithmic form to its exponential equivalent. That is, the equivalent of this will be x equal to e raised to n. Okay, that's antilog. Okay? Antilog, we are just changing the form of the logarithmic equation to its exponential equivalent. Okay? Okay, let's try to bring out the one important thing, one important relation here is the relation between the common logarithm and natural logarithm. Sometimes there are problems on the short videos, on the short speed. They are asking for the relation of the common logarithm and the natural logarithm, and we shall bring out now the relation between common logarithm and natural logarithm. So the relation of common and natural logarithm, we'll try to derive this one. Okay, let's try to bring out, we put x equal for, we assume x to be equal to 2 for the meantime. If we try to take the common logarithm, it will be 0.301, 0.29996. Common logarithm, sorry for that one. Natural logarithm of 2. This is common log, right? This is natural logarithm of 2. It's 0.693, 147,168. If we try to take the ratio of natural logarithm of 2 over common logarithm of 2, natural logarithm of 2 over common logarithm of 2, we'll just take the ratios, right? Natural log is this one, common log is this one. Okay, if we try to simplify this one, what will come out will be 2.3. Okay? But logarithm of 2 is actually at the bottom. So natural logarithm to 2 in general, for this given equation now, the natural logarithm of 2 will be equal to 2.3. This ratio here is 2.3. 2.3 times logarithm of 2. Right? There is a factor 2.3 over here. Meaning to say, there is a relation between natural logarithm and common logarithm, and that factor is actually 2.3. So in general now, the natural logarithm of any number should be equal to 2.3 times the common logarithm of that given number. Okay? The natural logarithm is bigger than the common log because there is a factor 2.3 over here. For these two things to be equal, okay, we will be multiplying common logarithm of x by 2.3 to be equal to natural logarithm of x. So in general, the relationship between natural logarithm and common logarithm of any given positive real number, it will be natural logarithm of x equal to 2.3 times the common logarithm of x. Okay, that's it. So at least we now know the laws of logarithm. We know how to get the anti-logarithm. To take the anti-logarithm, we'll just change the given logarithmic equation to its exponential equivalent. So after taking the exponential equivalent, we could say that we got already the antilog of that given number. And it is actually represented by this. So if the logarithm of x with the base of a is equal to n, if we try to take the antilog of this, what will come out should be x should be equal to e raised to n. This is expressed in exponential form. So exponential form is actually synonymous to anti-logarithm, and logarithmic form is actually with the logarithmic equation, right? So when we think anti-logarithm, it seems we are just being asked to change that logarithmic equation to an exponential equivalent to bring out the anti-logarithm. Okay, let's try to bring out an example problem illustrating the laws of logarithms and an example on how to take the anti-logarithm to bring out an answer for any given problem. Okay, the example problem, evaluate. This is just an what do you call this, an AC problem. An AC problem, but the main important thing here is just the concept that we use in the computation. It's an easy one, okay? Don't tell me it's an easy one. It's an easy one, but we are just, what you call this, presenting the concepts of the laws of logarithms to solve any given problem. Okay, evaluate x equal to the product of 986.7 times the square root of 7425 divided by 1000.1. When calculator is not yet out in this world, the old mathematicians before, they used to solve this one using logarithms. Okay? We don't have any calculator before. We use the so-called table of logarithms. That's why there is a logarithm solution. But now, if you try to solve this by using logarithm, somebody will be laughing at you because actually you can use your calculator. You just what you call this, place this value here on your calculator, and it will come out to be 85.01. Right? That's the millennial solution now by using the calculator. But before, the solution is actually by using the laws of logarithm. So this is just a presentation on how to use the concepts of logarithms. Okay, solution number one. Because there are two types of logarithms, right? The common logarithm and natural logarithm. So solution number one, by using the natural logarithm, if the base of the natural logarithm is 2.718 and so on, that's natural logarithm. Okay. Step number one, take the natural logarithm of both sides. The natural logarithm of x should be equal to the natural logarithm of open bracket, the product, over 1000.1 close bracket. If we try to simplify this one, the numerator falls under the product AB, and it falls under the natural logarithm of A plus natural logarithm of B, right? But there is a 1000.1 over here. So it seems we are having a ratio AB over C, right? For the simplification of the product AB, it will be this. And for C, since this is under the denominator, it should be minus. Right? Because this should be the natural logarithm of A plus the natural logarithm of B minus the natural logarithm of C. This is the total numerator. Okay? The simplification of the product will be this one. And for the denominator, it should be a minus natural logarithm of C. So this is the natural logarithm of a product A and B. Okay, to product. Minus the logarithm of the denominator, right? For a product, it should be the natural logarithm of the sum. It should be the natural logarithm of the first. For the second, it's a little bit complicated because there is a power 1/2 over there. But we could simplify this one by n natural logarithm of 7425. There is a power 1/2 here, but we could simplify this one because one of the laws of logarithm, we could bring it down, right? It should be n times the natural logarithm of 7425 minus the natural logarithm of 1000.1. I didn't bring out the values now, but I will give you the overall value of the right hand side. It will be 4.44 or 442.81475. That is the natural logarithm of x. So in here, we are now given a natural logarithm function. Okay? We must have to compute for x. We must have to eliminate the natural logarithm. Okay, and to eliminate the natural logarithm, we must have to take the antilog of both sides. And what's the proper way and how to take the antilog of both sides? We change this one, this logarithmic to exponential. What's the base of natural logarithm? It is e. So it will be e raised to the natural logarithm of x. And this should be equal to e raised to 4.428145. This is a logarithmic equation, and if we try to take the antilog of this, actually we are changing the form from logarithmic to exponential. So we will take the base, and we raise that base to the given left hand side, and for the right hand side, it will still be same base, e, raised to the given right hand side. But if we try to simplify this one, this will just be simply x. And the proper way to read this one is the antilog of the natural logarithm of x is just simply x. Okay? That's the topic, antilog. If we try to take the antilog of the natural logarithm of x, it will just be simply x. So e raised to the natural logarithm of x should be equal to x. And e raised to 4.428145, you can use your calculator, the value will be 85.01. So the value of x is actually 85.01. So without knowing the knowledge on how to get anti-logarithm, okay, you cannot bring out the correct answer. That's why I presented this concept here. I bring out this example so we know how to operate anti-logarithm. Anti-logarithm, we are just changing the form from logarithmic to exponential. Okay, solution number 2, it's the same. The only problem with solution number 2, the base is different. The base is 10, right? So the simplification, it will be same as this one. But we use common logarithm. Common logarithm of 986.7 plus 1/2, common logarithm of 7425 minus the logarithm of 1000.1. Okay, I didn't bring out the individual values of this, but if we try to take the equivalent of the right hand side, it should be approximately 1.921. That is the common logarithm of x is 1.921. Okay? 94101. This is actually logarithmic form. Right? So to compute for x, we must have to eliminate this log here. And to eliminate this log, we shall take the antilog. And to take the antilog, we will take the base. The base here is 10. And we raise that to the given left-hand side. And this should be equal to 10 raised to 1.921 for 94101. And here, the simplification is it is just simply x. Okay? Because if we try to read this one, the antilog of the logarithm of x will just be simply x. So x now will be 10 raised to approximately 2. Because if it's 2, 10 squared is 100, but this is 1.92. So the correct answer will be 85.1. Okay? So this is how we take the antilog of the common logarithm, the base raised to the given left-hand side. For the natural logarithm, it should be the base e raised to the given left-hand side. Okay? So meaning to say, when we take the antilog, we take the base, we raise that to the given left and right-hand side. Okay? That's it. This is 85.01. This is 85.01. This is an example problem illustrating the laws of logarithms and the proper way on how to take the logarithm. And to get the final answer, we will take the antilog. And the proper way on how to take the antilog, we take the base, we raise that to the given left-hand side and right-hand side. And what will come out will just be simply x. Okay? This is 85.01. This is 85.01. Okay, good evening from Los Angeles. Professor David J.